Okay, this is chapter 9, day 1, and this is one of the longest chapters we have in statistics because we're going to be talking about testing a claim. Some call this hypothesis testing, and it's not as hard as it may appear. Um, the big picture on this may or may not have been shown to you prior to this video. This video dives into the small parts of all of this, okay? So to start with, um, most of the time proofs are usually associated with geometry. And I have long contended that the modern proof really is in statistics. And if they don't call it a proof anywhere in a book about when they do hypothesis testing, they call it testing a claim, okay? So just like anything else, when you write a 5 paragraph essay in English, they give you what paragraph one is, two, three, four, and five. I don't know if they still do that or not, but there's all kinds of ways that they have you organize things. In statistics, we have a tradition of doing 4 parts. Okay, and those parts are state the hypothesis, state the conditions, run the test itself, and then state the conclusion. 5 has a star by it because sometimes they add another question. But it starts with doing a 4-part response to these questions. Okay. And by the way, of note, these 4 parts is how they got the original score of a 0 through a 4 on your FRQs, because the most common FRQ is to run a test or a claim, test a claim and see if it's true. This is done all the time in society. It may not be reported in a 4-part essay like this, but it's done all the time. Okay, so the first thing you're going to do is state the hypothesis, and HO is called the null hypothesis. I think that's Old English. I'm not really sure, but it's the null hypothesis. H sub naught or 0, H sub O. Some people call it the original hypothesis, which is where you get the O. That might be the English translation. And HA is the alternative hypothesis. And what HO is, and I'll say it in a minute, I'll repeat myself. HO is just the default position. It's just kind of what is traditionally known. HA is what you're really trying to prove. In a courtroom, HO would be innocent, because we always take the position that the person is innocent until proven guilty. HA would be guilty. You're trying to prove HA. And sometimes you don't have enough evidence to support HA, so HO stands, okay? Now, maybe the most modern, easy way to understand HOHA would be a football game. Very common. When they go to instant replay, and most people watch a football game, okay, the HO is that the ruling on the field was accurate. Ruling, I can't spell it. Ruling on field was accurate. What, writing this down. Accurate. Ruling on field accurate. That is horrible writing. Okay. And HA is that there's evidence to overturn it. So, okay. The HA would be there's video evidence to overturn it. Okay, evidence. And if you listen to a referee, they talk like a statistician when they report their findings. They'll say, there is no video evidence to overrule the original ruling, so the original call stands. HO stands. That's what they'll say. Okay, they don't say HO. They'll say the call on the field stands, or the original call stands. Okay, they are not saying that the original call was a good call. They're not saying that. They are saying that there is not evidence to overturn it. There's a difference. Once in a while, if you listen carefully, they'll say the video evidence confirmed the ruling on the field. That would say HO was the right call. Okay. So that might be, maybe your best example of how they do this. When they overturn it, they will say, we do have visual evidence to overturn that. Okay. And that they've confirmed that HA is true. So when you're doing a claim, you're trying to prove HA. And if you can't, you will report that you have no evidence to overturn HO. You won't say HO is true. You'll just say we have no evidence to overturn that. Okay, that's the idea here. Okay, that's a very long explanation, and I only did step one. State the hypothesis. And we're going to practice how to state hypotheses. They usually are stacked to be like this, HO colon, and then HA colon. And I'll show you how to do it. It's very, very easy to do. Okay. Then we've talked about this in the previous chapter. You have to go through, did you have a legitimate study taking place to try to overturn HO? Did you do a legit study? And that's that SPIN acronym. And you notice that is not new. That is something we did in the previous chapter. Okay. And to refresh your memory, S is we need to have a representative sample or a good sample. The P is the 10% rule. Do not violate the 10% rule. Or the population needs to be 10 times bigger than your sample size. I is independent. We all need independent data. That's if you follow government politics at all, the need for independent data is pretty important. Okay. And then N is a normal curve. And the way you establish a normal curve is a little bit different for a mean versus a proportion. But we'll go through all that again. Okay. So that's step two. Okay. Step three is going to be, you're going to calculate the test statistic. That is either a confidence interval or a p-value. So you're going to draw a normal curve and do your raw score, z-score percentile, which we've done. We did that in chapter 2, or you're going to do a confidence interval. You can do either one. Traditionally, you do a p-value unless a confidence interval is asked for. Okay, I'll say that again. Traditionally, you do a p-value unless a confidence interval is asked for. Okay. And then you'll state your conclusion. And when you have a conclusion, I have a sentence frame for this. I'll give you sentence frames. And then it's possible, I put a star here because they may ask you an additional question like a type 1, type 2 error. Type 1, type 2 error are probably better known in your world as false positives and false negatives, but we label them 1 and 2. And which one is worse depends on the situation. And human reasoning decides which one is worse. And we'll talk about how you control for type 1 and type 2 errors. It's very, very fascinating. Okay. So I'm just on the overview here, and I took a little bit of time. So that's just the overview of what we're doing. And it ends up being really quite simple to do. It's logical. So you'll get a blank piece of paper and you'll have a question, and they'll say, is there evidence to suggest that the drug works? And you'll set up a null and alternative hypothesis. Then you'll run through do they have the conditions met, which are often called assumptions? They're really requirements for legit study, but they often turn into assumptions because you don't know if the requirements have been met. So you say, I assume they've been met. And I'll show you how to do this throughout the chapter. This is a very long chapter, about 3 weeks. Okay. Then you'll run the stat, which you've done in the past, and then you'll state a conclusion, which I'll give you a sentence frame for. Okay. And it ends up being just like it's not like a 5-paragraph essay. It's just a 4-part thing, except you got drawings and intervals possibly, and then you have some prose as well. Okay. So I have a good formula for doing this. And the reason I'm videotaping day 1 is because it's very tedious. And I feel like if I videotape this might be one you might go back and look at multiple times. Okay. We are on step 1. Okay. We are on step 1. Okay. And some of this might get a little confusing, but in the end, it's not going to be difficult. Okay. All right. The null hypothesis is called HO. Okay. I have P equals, if you're talking about, if the problem is in the language of a mean, if the problem is a mean, you'll put mu equals, okay? If the problem is in a proportion, you'll put pi equals or p. I put p as an example, but it could be any three of those symbols. Remember, if the problem is a mean, use mu. If the problem is a proportion, I would use pi probably, okay, even though my example is p. Okay, and HO is always going to be every single time mu equals or pi equals. It's equals. And then there'll be a number. There'll be a number. And what an effect means, I wouldn't worry about this. I have an old example for that. Cross that out. Is that there's no effect, no difference, no change. Everything's the same. The original hypothesis could be innocent. That one I give you the example of could be innocent. Okay. All right. The alternative hypothesis, there's actually three symbols that can go in here. You're either going to put not equal to, okay, and the word will be there is a difference. A difference could be more or less. There's a change, okay, etc. Okay. You could put greater than, or you could put less than. Now, there's a lot of details in here, okay? Notice, I'm going to change colors here. Notice in the two-sided one, you'll be shading on two sides of the normal curve because not equal to is a two-sided concept. It could be much bigger or much less. If it's greater than, clearly you're going to shade only on the greater than side. And if it's less than, you're going to shade on the less than side. Okay? Now notice that I introduce the concept of alpha levels. Alpha levels are levels of proof. Wow. Now, if you go back to the football game idea, how much video evidence do you need? How much proof do you need? That is subjective, okay? There are two common alpha levels. The two most common ones are 0.01 and 0.05, okay? Obviously, 0.01 means you have to have a statistic that is so unusual that it would only occur 1% of the time or less, and that's your proof. If you're requiring less proof, then you could use 0.5, which is called the 5% proof level, meaning if you get a statistic that would only occur by chance, 5% or less, then you have proof, okay? And that's what 0.1 and 0.5 mean. Now, in practical purposes, they serve a very important purpose. Okay, when you have a very, very important case in court like murder, you want the alpha level very low. You want it hard to prove because you don't want to make the mistake of putting an innocent man in prison. Okay, when it's a shoplifting case, you're okay with the 5% proof or a little less proof, psychologically less proof, because if somebody was accused of shoplifting but really didn't, they were falsely accused, their punishment is time on the freeway picking up trash, but they'll get over that very quickly, but they won't get over imprisonment very quickly, okay? So humans adjust the alpha levels, 0.1 or 0.5. Academically, the problem will often say, use the 0.1 alpha level, okay? If that is not said, then you can pick either one that you want. But the common ones are 0.1 and 0.5. But theoretically, there's any alpha level available. Okay? So let's let me show you something real quick, okay? This is a little high level, but see if you can pick this up, okay? Alpha level 0.5, that is one-sided. One-sided is greater than or one-sided is less than, okay? Then if you have an alpha level 0.5 on one side, we're trying to figure out our rejection region, okay, which I'll get into later, but let me just show you this real quick. You're going to double 0.5 to make it 10%, okay, because it's one-sided. We're going to make it two-sided, make it 10%, okay. 0.5 doubled is 10%, and then go 100 minus 10%, that's 90. Now, I'm going to go to my table here that we have our year-long materials, 90% confident. Okay, that is going to be this 1.645 number right here. Okay, that's going to come into play later. Okay, if you don't quite get that right now, that's okay. Okay, now same thing here. Now, if it's going to be a two-sided test right here, and you have an alpha level 0.05. What I did was I put 0.025 on this side, 0.025 on this side, half of that, and I put 0.025 on this side. That leaves 95% in the middle. And everybody remembers 95% is 1.96. What I did here, don't freak out about. Just hold on. I'm just introducing it. Get it on paper. It'll come into play and it'll be okay. Now, I've shown you a lot. What we're going to do now is we're going to go and I'm just going to work with you on how to state the hypotheses. I'm back to step one. If you're asked a question, we're going to work just on this. That's it. Okay? So it's going to be easy. Okay, here we go. Let's say there's this situation. Ripples potato chips claim that each bag is filled with 12 ounces. However, the last 5 bags you purchased averaged only 11.4. I did this one time as a class. We weighed a bunch of chips like that, and they weighed less than advertised. And I sent an email to the makers of the company, and they sent us free potato chips. It was kind of fun. Anyhow, so here's the question. The question is, do you think that they are underfilling the bags, right? So your HO, your null hypothesis, and by the way, this is a mean. This is not a proportion, this is a mean. So HO, mu is 12, okay? And your HA is, I think it's possible its mu is less than 12. This is a one-sided claim. You're not suspecting that they overfill them. That's not a suspicion, okay? So, and the question is, does this statistic, 11.4, is that enough evidence to prove that they're underfilling the bags? I don't know. We're not doing that right now. We're just doing step one is to write it out. So that is step one. Write your HOHA. Easy. Now let's go to 1B. And again, I'm doing this in terms of a mean. So I'm using mu, okay? The average wait time for a traffic light is supposed to be 70 seconds. That's like a minute, 10 seconds, right? Jake measured the wait times at 4 traffic locations. He got these 4. All right. And he's wondering if it's different. Different could be quicker or slower. He's not really sure. He wonders if it's different. All right, fine. So HO, mu is 70. It is as claimed. And then HA, what he's trying to prove with this statistic, he thinks it's not 70. Okay? Again, don't worry about the other parts. Just worry right now. Can you write a legitimate, null, and alternative hypothesis? I think you can. Okay, 1C. Mr. Nguyen said that the next test would be very difficult, predicting an average score of 68. However, the class felt it wasn't too bad since 12 people averaged 84 in his practice test. Wow. Okay, good. So HO is going to be, yes, it's going to be 68, but the kids think they're going to score higher than 68. Notice on all of these, HO and HA, the numbers are the same every time. Notice that the first number is always equal to, and the second number is going to be something in context of the problem. I have a less than, a greater than, and a not equal to. Item B, I'm not sure really if it's less than, greater than, or not equal to. And if you're not sure, that's why you put not equal to. Okay. All right. So that is how you do that. Now, real quick, I want to go back over how to line up alpha levels with confidence levels. Back over that, okay? And this kind of gets in between step one and other steps. I just kind of want to cover this, okay? So if you notice up here, I was talking about this, all right? I was talking about all that up here. And I'm going to do that again. I think this time you're going to get it pretty good. All right. So I got a bunch of these. For each case, determine the missing alpha or confidence level that would be consistent for a one-sided versus two-sided test. No problem. Okay. All right. So this is two-sided language. And if the confidence level is 90%, if you ran a test with an alpha level, you would just go 100 minus 0.9. That would be Alpha is 10%, the 10% level. Okay. All right. Now let's go to E over here. In this case, let's say we got, this is less than right here. That's one-sided. And this is a 95% confidence level. So what that means is that there's 5% left here and here. Okay. So we know that that was, it's one-sided. So what happened is that we're going to have 2.5% on each side, and that's going to equal the 5% added to 95 to get to 100. Okay. Okay, F. Okay, this is one-sided. Okay, and we have a confidence level of 90. So let's again draw that out. Here's 90% in here, right? The middle 90. That means 5%'s here and 5%'s here. Okay, and this is a one-sided test. So that's right. Alpha is going to be 0.05. So if you double it, you'll get 10. Take it, add it to 90, and you get 100. Okay. All right, G. Again, this is one-sided, and we have an alpha of 0.05. So I must double that to make it two-sided. Now it's 10%. 100 minus 10% is 90%. I hope you're getting the hang of it. Okay, next. Two-sided. Alpha is 0.05. That's already two-sided. So there's 2.5% on each tail already. So you go 100 minus 5% and you get 95. Okay. I, one-sided. So I got to double 10% and make it 20%. 100% minus 20% is 80%. Okay. This one-sided. I'm going to take this alpha and I'm going to double it, make it 0.01 to 0.02, which is 2%. 100% minus 2% is 98%. Okay. And then K, I have a two-sided one. So it's already two-sided. That means there's 1% on each side, making the 2% alpha already. So I'm going to go 100% minus 2%, and I get 98%, and I have the wrong answer. That happens sometimes. You know what I mean? 98%. Thanks for checking that. Okay. Whew, glad I got that. Okay. So what we've done so far, we have really just done state the hypothesis, and then I talked about alpha levels because that's going to be needed. Okay. Sound good? We're on to step 2 now. Step 2 is state the conditions, assumptions, spin. We've done this before. We have done this. Okay. All right. And when we start doing some of these, we start doing the whole picture on this, it'll be really easy. We're just going step by step. Okay, now we're going to write in a couple things here. Remember, I'm not going to spend long on step 2 because we know this. So this would be for a proportion, correct? Proportion. For a mean, we need it to be greater than 30. We need the box plot to be somewhat normal, okay? We need the prompt to state normal. One of those things has to happen. Okay? So for the mean, there's 3 ways to prove normality. Greater than 30. The box plot's approximately normal. If you have the data, draw it out. The prompt states it's normal. Okay, for a proportion, we have one choice. That's it. Okay, we did this in chapter 8 and touched on it in 7, so we're good to go. All right, now, next step. This is going to be so easy for you, okay? And there's even a shortcut later on, but for right now, we're going to take the long cut on this. Okay, we are going to be doing t-scores and z-scores. Remember, I'm going to write this out, and you may want to make a note of that. We're going to do a T for a mean, and we're going to do a Z for a proportion. And there's going to be really cool shortcuts later. I will not show you the shortcuts today, okay? Now, and I'm going to do these from the perspective of a mean. I think most of the ones I do here, okay? And I'll show you something new on the, I'll show you one thing new in the calculator, and then I'll show you the shortcut in subsequent lessons. Okay, so we have seen raw score, z-score, percentile forever, and we know the formula to get a standard score. We're used to seeing this as a z, but for a mean it'll be a t, okay? And we know it's your statistic minus the parameter, and this is what's in HO, mu, divided by the standard deviation. But for our calculator, we're going to use something called TCDF instead of NCDF. It's pretty simple. We've done it, okay? So it's going to be really cool. All right, so here we go. We're going to do this, all right? Slide down here. So we're just going to calculate the statistic, which is called the p-value, okay? Here we go. So I have no context, but let's say HO mu is 83 and HA it's not 83. And we got a simple random sample of 23 that yields a mean of this and a standard deviation of that. Okay, no problem. So do you guys remember how to find the t-score? So take your time, and again, I always say in these videos, stop at any time you need to and work through it. Go nice and slow. This is not meant to be done quickly. Go nice and slow. Okay, so here we go. So we have our statistics, 79.5. We're going to subtract HO, okay? And we're going to divide by the standard deviation of that stat. And we get a t-score of negative 2.268, all right? And we're going to change this into a p-value. We know how to do that. We know how to do that, okay? So negative 2.268, I get that. The degrees of freedom is 82, right? No, I'm sorry, 22. 23 minus 122. Here we go. So I'm going to bring up the calculator. This is new for you, okay? So it's going to be pretty cool. We're going to go, let's see here. Second distribution. You guys are used to using NCDF, okay, for a z-score. Now we're going to, I wish it was ZCDF, but they don't call it that. TCDF. Here we go. And the problem said it was not equal to, okay, but I need to get the tail of it, right? So it was a negative 2.268. All right, here we go. So I'm going to get the tail of that. TCDF hit, and so let me draw out what we're doing real quick so you see it, because maybe you don't see this. Okay, so we have this situation, right? And we have a t-score of negative 2. I keep forgetting the number. That's what happens when you get old. Negative 2. I'll go 2.26. I'll use the whole thing. Negative 2.268. All right. Negative 2.268, right? Okay, so it's somewhere down here. I'm getting this tail right here. Okay, I'm getting that tail. All right. So when I get that, so I have the mean of this thing was like 83, and then there was an X bar score, right? We had so raw score, z-score, percentile. I'm converting it to this. Okay, so I'm going to get this tail, which is negative infinity, and then this number 2.268, if you recall that. Okay, so let's try this. All right. So in TCDF, enter, and there is infinity. That's good. I got that. And then the upper boundary was negative 2.268, and degrees of freedom was 22. It was a sample size of 23 minus 122. All right. So 0.0167 is the tail, but this is two-sided. It's two-sided because it had a not equal to. So I have to multiply this by 2 and put it on this side as well. Okay, so let me clear that. And we'll go to the answer. I'll go times 2, I guess, real quick. Times 2. There we go. 0.0335 is the answer to that. 0.0335. And let's see what we got here. Yeah, 0.033. I guess I went out before, but you get the idea. All right, let's go to B. I'll try to go nice and slow on B here as well. Okay, show you the big picture of this. Okay, HO, mu is 52. This is one-sided. We think it's actually less than 52. And a sample of 58 yielded an X bar of 50. That's not too much less, so we might not have evidence. And a standard deviation of 9.2. Okay. So what I'm going to do is I'm going to go ahead and draw this out. I got to get those, remember those pertinent numbers. Let's see here, 52. Okay. So the first thing I got to do is I got to get the t-score. There we go, right there. So if I'm drawing this out, I'll try to place it over here. Okay, might help like this. Okay, so what we got is you got the 52 is the middle, right? We think that's mu. The standard deviation is 9.2 divided by the square root of 58. Remember that? And then the statistic was 50.2. 50.2, right? 50.2. All right. And then if you calculate that, right, 50.2 minus 52 divided by the standard deviation, you'll get a t-score. Remember, raw score, z, or I'll put t this time. It's negative 1.49, right? Okay. And then I'm going to convert that to a p-value. You see the answer here. We're going to convert that. Okay. So let me slide over now to the calculator. Let's check it out. All right. So you can see this pretty good here. All right. So, all right. So I'm going to go second distribution, and I'm going to go not NCDF. That's for Z scores. This is for a T score. So I'm going to go TCDF. And I'm going to show you a cool shortcut later on in the chapter. Okay. And I need the low side because I had the negative one. So I'm trying to get this part right here. Okay, it was less than. Okay, so we got infinity down at the bottom, and then we got negative 1.49 up there. The degrees of freedom is 57. That's the sample size here where my cursor is, -1. Paste that. We should get about 8%, or no, 7%, 0.0709. There's a 7% chance this would happen by chance. That is not enough to change your mind at the 0.5 level. It has to be less than 0.5. And it's not enough to change it at the 0.1 level either. Okay? All right. So that's the second one. I'm going to clear the drawings on that one. Go ahead and clear this while I'm at it. Next one. Okay? So the next one we have, what do we got there? We got mu is 115, and we have a greater than, we have a one-sided situation. Okay, mu is, okay, so we think it's greater than 115. Okay, and then the sample size is 24, which makes it degrees of freedom 23. Our statistic came in as 119. That is a little bigger than this. But is it big enough to say that we don't think it's 115 anymore? I doubt it. Look at the p-values. It's bigger than 0.1 and 0.5, so you don't have enough evidence, okay? All right, so if you do the t-score right here, right, you're going to go the statistic, 119 minus 115 divided by 18.7 over radical 24, okay? All right, so let's go to the calculator and let's check this one out, okay? So I may have to go back and forth a little bit on this, but maybe I can pick it up off my notes here. Now I got it on my notes here, which is great. Okay, so let me slide over there to the calculator. Let's see if we can do this. Okay, so let me draw it out first. On the drawing, remember it's going to be raw score, Z score, in this case the T score, and the percentile. That percentile is called p-value, okay? So in the middle goes your HOHA number. If you're looking at your notes, that's 115, okay? Then the statistic is 119. That's somewhere over here, 119, okay? And this is a one-sided one. It's greater than. Notice that HA is greater than, so I'm going to shade it on the greater than side, okay? Here's your standard deviation, should be 18.7 divided by the square root of 24, okay? And then when we do that, when you do to get a t-score, let me slide back over to see what the t-score was. I don't have that on me. The t-score ended up being 1.048. Okay, that ended up being a t-score, 1.048. All right, so the t-score on this after we do our math is 1.048, okay? And then I'm gonna get the percentile, okay? This is gonna be TCDF down here. Here we go, okay? Second distribution, go to TCDF. Again, NCDF is for z-scores. I wish it was called ZCDF, it'd be better. And this is t-scores, this is for means, okay? And this time I need 1.048 as my lower bound. The upper bound is going to be infinity, which I will put in as a gigantic t-score. And the degrees of freedom is going to be 23, which is 24 minus 1, which is 23, okay? All right, and here should be, there we go, about 15% chance this would happen by chance, okay? 0.1528, 0.1528, okay? All right, so if you need to pause that, go ahead and clear this, go back to, yeah, 0.1528. All right, now look, we're really working on these in isolation. You may have had an opportunity by your teacher, me, or whoever, to see the big picture first. Eventually, you're going to see the big picture of this, and it's going to flow a lot better. We're doing the individual skills right here for the whole system to work. So let me slide back up, and let's talk about these skills one more time, okay? See what we can do here. Okay, whoops. There we go. Okay, so going back up at the top here, let's look at all we've done. We have worked on how to state the hypothesis. We already knew how to state the conditions. And frankly, we already knew how to get a p-value. The difference is you learned TCDF. I also threw in alpha levels, and it's all going to come into play here soon, okay? And now we're going to work on stating the conclusion or the inference, okay? What are you inferring? Inferring is making a judgment, okay? So here we go. Let's give it a try. Okay, right here. So let me get it right here. All right, here we go. So the first thing we're going to do is we're going to talk about what the meaning of the p-value is. You need to memorize this. I would definitely take a highlighter and highlight these because you have to memorize what p-value means. There's a meaning of it. Okay, this p-value was about 3%. So I'm going to use the phrase 3% when I read. And the meaning of it is if HO is true, then 3% of all samples would yield the observed results in this sample or mark stream, okay? There's another way to put it. If you want to listen to this, I'll say it to you. There's a 3% chance we would get results this extreme even if HO is true. You can often reverse that, okay? So I'll say it, I'll read it both ways each time. For example, B, if HO is true, then there's about a 7% of all the samples would yield the observed results in this sample or mark stream. I almost prefer the second one that I say, okay? There is a 7% chance we would get data this extreme, even if HO is true. That's another way to write it, okay? I'm gonna say that other one, and I would write down both of them and you can pick. I prefer the second one. A teacher friend of mine prefers the first, which is fine. For 3C, I would say there is a 15% chance that we would get data this extreme, even if HO is true. That's how I would do p-value, okay? So write what I said verbally down and write an example of these down. And maybe you don't have to write all three of them down. Maybe just write it once. I mean, you don't need to write all three of them. It's all the same sentence frame, okay? Okay, be able to state the conclusion of a test, okay? The conclusion, this is pretty cool. And this makes the greatest catchphrase, okay? Now, if the p-value is less than alpha, your first sentence frame is going to be reject HO. I bolded reject, pretty important word. And then you're going to say there is sufficient evidence to conclude, and then you're going to write HA, whatever HA is. And we're going to practice all this, okay? Now, if the p-value is greater than alpha, you will just say fail to reject HO. You're not going to accept HA. You're going to fail to reject HO. And then you're going to say there's insufficient evidence to conclude HA. And you're going to write HA in context, not HA, right in context. So get those sentence frames down. Most people love my little catchphrase. It's a rhyme. It's a rhyme. I'm a rhymer. I'm not a poet. If the p-value is low, then you reject the hoe. If the p-value is low, you reject the hoe. Okay, that's a good one. Okay. Here's the meaning of p-value. I got it again. Go ahead and write that down. And statistically significant, just so you know, if something is too unlikely to have happened by chance, then you can conclude HA is true, okay? Imagine imagine 4 kids being absent, and they never are absent before, they're never absent, and they're all absent on the same day and they're best friends. What would the probability of that happening by chance be? Not real good, okay? So that would be statistically significant that we found something like that. Okay, now let's get into type 1 and type 2 errors, which you guys know as false positives and false negatives. I won't get too specific now, but I'm just introducing it. And this is step 5. Let's go all the way back, okay? I've walked through all 5 of these, okay? And I've done it all in theory, so it's kind of hard to pick up. But when you finally get a real problem, it's all going to make sense, okay? I'm teaching you how to write like a 5-paragraph essay, okay? In this case, it's how to step-by-step how to do a hypothesis test. All right. Sometimes you reject HO, but you were wrong. Sometimes you find out later you were wrong. Sometimes the data's off, right? If you reject HO, but you were wrong, that's a type 1 error, okay? If you fail to reject HO, okay, and something went wrong, that's a type 2 error. Just get that written out, and we're going to deal with that more later, okay? All right, that's a long lesson. That is chapter 9, day 1. All right, of a very long chapter. We need a few of these to get you through it. All right, see you later.